Okay, welcome back students for the discussion of hybridization concept. Okay, in the last class of the hybridization we have discussed the two molecules. First one is the methane molecule, second one is ethene molecule. In case of the methane molecule we have studied sp3 hybridization, means 4 bonds are formed by the carbon atom. And in case of the ethene molecule, we have studied sp2 hybridization. Okay, now today let us move towards the next molecule of our syllabus, that is BCl3 boron trichloride molecule. It is undergoing sp2 hybridization. How it is known? How it is identified? It is undergoing the sp2 hybridization. See here. ಇದು sp2 hybridization ಆಗ್ತದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದ್ರಿಂದ see here one boron molecule is there. Okay, one boron molecule is there. One boron and 3 chlorine atoms are there in the boron trichloride molecule. It means there is a formation of 3 BCl bond. 3 BCl bond. 3 BCl bond ಗಳ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವಲ್ಲ ಅಂದ್ರೆ 3 ಬಾಂಡ್ ಗಳ ಬೇಕು ಅಂದ್ರೆ ಬೋರಾನ್ 3 ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಗಳನ್ನ ರೆಡಿ ಮಾಡ್ಕೋಬೇಕು ಅಂತ ಅರ್ಥ. ಬೋರಾನ್ should form 3 hybrid orbitals. Okay, it means in which hybridization we can get the 3 hybrid orbitals. ಯಾವಾಗ ನಾವು 3 orbitals ಇರ್ತಾವೋ in sp2 hybridization. Therefore we can say that boron trichloride molecule will undergo sp3 hybridization. Okay, next molecule, next point. See here, I will write the electronic configuration of the boron in a ground state. Boron for ground state. What is the electronic configuration? 1s2, 2s2, 2p1, 2px1. Okay, because its atomic number is 5. Other atomic number is 5. Its electronic configuration is this one. In the exact state, what happens? Boron. In the exact state, it will form 1s2. One of the paired electron in s orbital will be get unpaired. Get unpaired. Unpairing it becomes 2s1, 2px1, 2py1. It means here. Let us write one more electron configuration here for chlorine. I will write atomic number 11. I will write only the valence shell configuration. Valence shell configuration. Valence shell मात्र बरीते नोडल. Neon up to 10 I have wrote down here by writing the neon. 3s2, 3px2, 3py2, 3pz1. This is important here. 2s1 orbital means 2s orbital, 2px orbital, 2py orbital of the boron undergo hybridization. ಯಾವ hybridization ಅಂತಂದ್ರೆ 2s, 2px, 2py undergo hybridization and form 3 sp2 hybrid orbitals. 2s, 2px and 2py orbital of the boron undergo hybridization to form 3 sp2 hybrid orbitals. These 3 sp2 hybrid orbitals are oriented planar trigonal. ಅವು ಯಾವ ರೀತಿ ಅರೇಂಜ್ ಆಗ್ತಾವು? In a trigonal planar arrangement, they will be arranged with a bond angle of 120 degree. With a bond angle of 120 degree to minimize the repulsion between the orbitals. What should they arrange? They should arrange in this manner to minimize the repulsion between the orbitals containing electrons. ಅವುಗಳಲ್ಲಿ electrons ಗಳು ಇರುತ್ತವೆ ಆರ್ಬಿಟಲ್ ಗಳಲ್ಲಿ, ಅವುಗಳ ಮತ್ತೆ ರಿಪಲ್ಷನ್ ಅನ್ನು ಕಡಿಮೆ ಮಾಡುವಾಗ ಅವೇನ್ ಮಾಡ್ತಾವೆ? ಟ್ರಯಾಂಗುಲರ್ ಪ್ಲೇನಾರ್ ಅರೇಂಜ್ಮೆಂಟ್ ಒಳಗ ವಿತ್ ಅ ಬಾಂಡ್ ಆಂಗಲ್ 120 ಡಿಗ್ರಿ they will be arranged. It is the structure. ಇಲ್ಲಿ ಈ ರೀತಿ ಅರೇಂಜ್ ಆಗುತ್ತೆ. What these three are? These are 3 sp2 hybrid orbitals of the boron. With these 3 sp2 hybrid orbitals of the boron, half filled 3pz orbital of the chlorine. This is half filled. 3pz orbital of the chlorine make the bond formation axially to form 3 boron chloride sigma bond. ಈ 3pz ಆರ್ಬಿಟಲ್ ಏನು ಮಾಡ್ತದೆ? ಕ್ಲೋರಿನ್ ಅದು ಈ 3 sp3 ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಗಳ ಜೊತೆಗೆ ಸಿಗ್ಮಾ ಬಾಂಡ್ ನ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತದೆ. ಸಿಗ್ಮಾ ಬಾಂಡ್ you already know that in the last class we have discussed, the previous class we have discussed. You know about the sigma bond formation. Means the 3pz orbital overlaps axially with the 3 sp2 hybrid orbitals by the 3 chlorine atoms. ಇದು ಒಂದು ಕ್ಲೋರಿನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬರ್ತದೆ. ನಾನು ಇಲ್ಲಿರೋದು 3 ಕ್ಲೋರಿನ್ ಆಟಮ್ಗಳು. 3 ಕ್ಲೋರಿನ್ ಆಟಮ್ಗಳಲ್ಲಿ ಇರತಕ್ಕಂತಹ ಒಂದೊಂದು 3pz ಆರ್ಬಿಟಲ್ ಹಾಫ್ ಫೀಲ್ಡ್ ಐತಿ, ಅದು ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಗಳ ಜೊತೆಗೆ ಓವರ್ಲ್ಯಾಪ್ ಆಗ್ತದೆ. It is like this. P orbital is having dumbbell shape, is it? You all know that one. This is one p orbital. This is one more p orbital. Okay, here we will have one more p orbital. They are making what? The bond formation here and form 3 boron chlorine sigma bonds. This is the structure for the boron trichloride, and the bond angle will be 120 degree. This is about what? The boron trichloride molecule with the sp2 hybridization. Okay, next move towards ethyne molecule. Okay, you all know that ethyne is having carbon-carbon triple bond and 2 hydrogen atoms. Carbon-carbon madhye triple bond aitalla. Okay, look at here. This is undergoing sp hybridization. adu sp hybridization na ಹೆಂಗ ಆಗ್ತದೆ ಅಂತಂದ್ರ ಅದನ್ನ ನೋಡ್ಕೊಳ್ಳೋದು ಫಸ್ಟ್ ಈಗ. ಓಕೆ, ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಮಧ್ಯೆ ಒಂದು ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಇದೆ. ಯು ಆಲ್ರೆಡಿ ನೋ ದಟ್ one bond is sigma bond, another 2 are pi bonds. ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಮಧ್ಯೆ ಇರತಕ್ಕಂತ 3 ಬಾಂಡ್ಗಳಲ್ಲಿ ಒಂದು ಸಿಗ್ಮಾ ಬಾಂಡ್ ಐತಿ, ಉಳಿದಿದ್ದ ಎರಡು ಏನದಾವ? ಪೈ ಬಾಂಡ್ಸ್ ಅದಾವ. ಓಕೆ, ಈ ಪೈ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಾಕ, for the formation of these pi bonds, hybridization is not necessary. ಇದಕ್ಕೆ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಬೇಕಾಗಿಲ್ಲ. ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಇಥಿನ್ ಮಾಲಿಕ್ಯೂಲ್ ಆಗುವಾಗ ನಾನು ಹೇಳಿದೆ, ಇಲ್ಲಿ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಾಕ, ಪೈ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಾಕ ಹೈಬ್ರಿಡೈಸೇಷನ್ ನೆಸೆಸರಿ ಇಲ್ಲ. ಅದು ನೆಸೆಸರಿ ಆರ್ಬಿಟಲ್ಗಳು ಬೇಕಾಗಿಲ್ಲ. ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಗಳು ಪೈ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಮಾಡಾಕ ಬೇಕಾಗಿಲ್ಲ. ಪಾಯಿಂಟ್ ನಂಬರ್ 1 ಗೊತ್ತಿರಲಿಲ್ಲ. For the sigma bond formation, hybridization is necessary. It means here one sigma bond is present between carbon and carbon. One sigma bond is present. It means here the hybrid orbitals are overlap between 2 carbon atoms to form one carbon-carbon sigma bond. ಅಂದ್ರೆ ಇದರಿಂದ ಒಂದು ಆರ್ಬಿಟಲ್ ಯೂಸ್ ಆಯಿತು, ಇದರಿಂದ ಒಂದು ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಕಾರ್ಬನ್ ಮಧ್ಯೆ ಸಿಗ್ಮಾ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಕ್ಕೆ ಯೂಸ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಒಂದು ಹೈಡ್ರೋಜನ್ ಐತಿ, ಅದಕ್ಕೂ ಏನ್ ಬೇಕಂದ್ರೆ ಏನ್ ಬೇಕು? ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಬೇಕು. Here also hydrogen has formed one sigma bond with the carbon. Here also one hydrogen has formed the one sigma bond with the another carbon atom. It means for one carbon, two hybrid orbitals are necessary. For one carbon, two hybrid orbitals are necessary. One hybrid orbital makes the bond with one more carbon atom, and another one hybrid orbital makes the sigma bond with the one hydrogen atom. Point go through like that. It means for one carbon, two hybrid orbitals are necessary here in the ethyl molecule. Please understand this one. Okay? I will write directly the excited state configuration of the carbon. You are already know about the ground state electronic configuration of the carbon. Now directly excited state. Here one more point. In ethyl molecule, two carbon atoms are there, two hydrogen atoms are involved. Carbon excited state configuration. Excited state configuration, that is 1s2, 2s1. ಇಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ p ಹೋಗಿರ್ತದೆ, 2px1, 2py1, 2pz1. ಇದೆಲ್ಲಿಂದ ಬಂತು? ಈ s ಆರ್ಬಿಟಲ್ ಇಲ್ಲಿ ಒಂದು ಜಂಪ್ ಆಗಿದೆ. This is excited state electronic configuration for the carbon. Okay, here see here. Here what happens? One 2s orbital and one 2p orbital of the carbon atom of both the carbon atoms undergo hybridization. Hybridization ಯಾವುದು ಅಂತಂದ್ರೆ one 2s orbital and one 2p orbital of the both the carbon atoms. ಎರಡು carbon atoms ಇದೇ ರೀತಿ ಆಗ್ತಾ ಇದೆ. Of both the carbon atoms undergo hybridization. These 2py and 2pz orbitals non-hybridized. ಅವು hybridization ಆಗಿಲ್ಲ. ಪಾಯಿಂಟ್ ನಂಬರ್ ಗೊತ್ತಿರಲಿ. ಇವು unhybridized or non-hybridized orbitals of both the carbon atoms. ನಾನು ಏನೇ ಕಾರ್ಬನ್ ಹೇಳಿದ್ರು ಎರಡು ಕಾರ್ಬನ್ಗೆ ಅದು ಅಪ್ಲಿಕೇಬಲ್ ಆಗ್ತದೆ, ಗೊತ್ತಿರಲಿಲ್ಲ. Here 2s orbital and 2p orbital, one 2s and one 2p orbital of the both the carbon atoms are undergoing hybridization and forming two sp hybrid orbitals. Two sp hybrid orbitals in both the carbon atoms. ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಎರಡು sp ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಸ್ ಗಳನ್ನು ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತು. ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಕೂಡ ಎರಡು sp ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಸ್ ಗಳನ್ನು ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತು. ಓಕೆ, here out of two sp hybrid orbitals from the two carbon atoms one hybrid orbital is used to make the sigma bond with the two between the two carbon atoms. ಎರಡು sp hybrid orbital ಗಳಿದ್ವು, ಅದರೊಳಗ ಇದರಿಂದ ಒಂದು sp hybrid orbital, ಇದರಿಂದ ಒಂದು sp hybrid orbital sigma bond ನ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವು. sigma bond means they have overlap axially. Here axial bond is formed. Axial overlapping is done between this carbon atom of the hybrid orbital and hybrid orbital of this carbon atom. ಗೊತ್ತಿರಲಿಲ್ಲ, ಇದರಿಂದ ಒಂದು ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್, ಇದರಿಂದ ಒಂದು ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಸಿಗ್ಮಾ ಬಾಂಡ್ ನ ಈ ಕಾರ್ಬನ್ ನ ಮಧ್ಯೆ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತು. Okay, now what is happening here? Next, here one hybrid orbital is there of this carbon atom. Here one hybrid orbital is there of this carbon atom. These hybrid orbitals make the axial overlapping with 1s atomic orbital of two hybrid orbitals separately. ಅಂದ್ರೆ ಈ ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಇಲ್ಲಿ ಒಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಜೊತೆಗೆ axial overlapping ಮಾಡ್ತದೆ. ಇಲ್ಲಿ ಇರತಕ್ಕಂತ ಈ ಕಾರ್ಬನ್ ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಈ ಹೈಡ್ರೋಜನ್ ಜೊತೆಗೆ axial overlapping ನ ಮಾಡ್ತದೆ. Axial overlapping means what? It is the formation of sigma bond between carbon and hydrogen. ಈ ಕಾರ್ಬನ್ ಮತ್ತು ಈ ಹೈಡ್ರೋಜನ್ ನಡುವೆ ಇಲ್ಲೊಂದು ಏನಾಯ್ತು sigma bond formation ಆಗ್ತದೆ. It means in ethyne molecule there exist two carbon hydrogen sigma bonds. ಅಲ್ಲಿ ಎರಡು ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಸಿಗ್ಮಾ ಬಾಂಡ್ಗಳು ಫಾರ್ಮೇಷನ್ ಆಯಿತು. ಓಕೆ, ನೆಕ್ಸ್ಟ್. Now I have explained each and everything about the hybrid orbitals. Now I need to explain about unhybridized orbitals. Unhybridized orbitalಗಳ ಬಗ್ಗೆ ಮಾತ್ರ ನಾನು ಈಗ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಅನ್ನು ಕೊಡ್ತಾ ಇದ್ದೀನಿ. Okay, look at here. Now these are unhybridized orbitals. Look at here. Unhybridized orbitals. These are unhybridized orbitals. ಯಾವ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ 2p1 2pz of both the carbon atoms. ಇದರೊಳಗೆ 2p1 2pz ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಒಳಗೂ 2p1 2pz orbitals. ಇಲ್ಲಿ unhybridized orbital ನಾನು ಸೆಪರೇಟ್ ಆಗಿ ಶೇಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. These are unhybridized orbitals. These unhybridized orbitals of both the carbon atoms make the sideways overlapping to do what? To form sigma bond. To form sigma bond. Sigma bond formation pi bond formation ಮಾಡಕ್ಕೆ ಏನು ಮಾಡ್ತಾವು ಅವು sideways overlapping ನ ಮಾಡ್ತಾವು. This is one orbital, this is one orbital. This orbital is making bond with this orbital. Here one more orbital is there which is unhybridized. It will make the bond with this orbital. Okay, this is pi bond. The ಎರಡು pi bondಗಳು formation ಆಯಿತು ಅಲ್ಲಿ. This is what. And one more thing I want to explain you. Here I want to tell only one thing here, that is geometric shape. Geometric shape of ethyne molecule, that is like this. Okay, orbital ಯಾವ ರೀತಿ ಇದಾವ? ಇಲ್ಲೊಂದು ಆರ್ಬಿಟಲ್ ಐತಿ, ಇಲ್ಲೊಂದು ಆರ್ಬಿಟಲ್ ಐತಿ, ಇಲ್ಲೊಂದು ಆರ್ಬಿಟಲ್ ಐತಿ, ಇಲ್ಲೊಂದು ಆರ್ಬಿಟಲ್ ಐತಿ. How they are arranged? They are arranged linearly with a bond angle of 180 degree. It means geometrical shape is linear with bond angle of 180 degree. This is about what? The ethyne molecule formation with the sp hybridization. Okay, yes. Okay, now let us move towards the fifth molecule in hybridization concept, that is PCl5, means phosphorus pentachloride. It is forming or it is undergoing the sp3d hybridization. How it is? No, how it is understand? It is undergoing the sp3d hybridization. This sp3d hybridization ಮಾಡ್ತಾ ಇರೋದು ಹೆಂಗೆ ಹೇಳೋದು? ಇಲ್ಲಿ ನೋಡಿ, one phosphorus is there. It is making 5 bonds with the chlorine atoms. 5 different chlorine atoms. It means here one phosphorus is there and 5 chlorine atoms are there. All are making 5 phosphorus chlorine bonds. ಹಾಗಾದ್ರೆ ನನಗೆ 5 ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಗಳು ಬೇಕು ಅಂತ ಅರ್ಥ. ಬಾಂಡ್ ಎಷ್ಟು ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ? 5 ಬಾಂಡ್ಗಳು ಬೇಕಾಗಿವೆ ಅಂತಂದ್ರೆ ಫಾಸ್ಫರಸ್ ಇಂದ ಅಂದ್ರೆ 5 ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ಗಳು ಬೇಕು ಅಂತ ಅರ್ಥ. ಅಂದ್ರೆ 5 ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಬರ್ತಕ್ಕಂತ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಯಾವುದು? ದಿಸ್ ಒನ್ 1s 3p ಟೋಟಲ್ 4 ಆಯಿತು and 1 from the d. It is making sp3d hybridization here. ಈಗ sp3d hybridization ಆಯ್ತು. Okay, here, yes, here one phosphorus atom is there and 5 chlorine atoms are there. One phosphorus atom is there and 5 chlorine atoms are there. You know that? Phosphorus pentachloride molecule. Phosphorus pentachloride olaga ಒಂದು phosphorus and 5 chlorine atoms are there. Okay, now let us write the electronic configuration of phosphorus. Okay, this is neon. It means I have wrote down up to the 10. 3s2, 3px, 3py, 3pz. 10 plus 2 12. And the no more electron bariಬೇಕು ನಾನು 3px1 3py1 3pz1. Look at here. Here only 3 orbitals are there. 3 half-filled orbitals are there. But I need 5 orbitals. 5 orbitals for the sp3d hybridization. ಅದಕ್ಕೆ ನಮಗೆ 5 ಆರ್ಬಿಟಲ್ಗಳು ಬೇಕು. ಇಲ್ಲಿ ಇರತಕ್ಕಂತ 3 ಮಾತ್ರ ಅಂದ್ರೆ ಎಕ್ಸೈಟೇಷನ್ ಮಾಡಬೇಕು ನಮಗೆ ಈಗ. Okay, then what happens? Phosphorus in excited state. See here. Phosphorus in excited state. What happens? This paired electron in s orbital of the phosphorus gets unpaired and jumps to the 3d orbital, 3dxz orbital. 3d ಯಾವುದೇ orbital ಬೇಕಾದ್ರೂ ನಾವು ತಗೋಬಹುದು ಇಲ್ಲಿ. 0 ಇಲ್ಲಿ 0 ಇತ್ತಲ್ಲ, ಇದಕ್ಕೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ jump ಆಗ್ತಕ್ಕಂಥದ್ದು. Let us write that. I will write only electron configuration of the valential orbitals. 3s1, 3px1, 3py1, 3pz1, 3dxz1. 5 orbitals are. Okay, 5 orbitals are available now for the hybridization. ಈಗ hybridization ಗೆ ನಮಗೆ 5 ಆರ್ಬಿಟಲ್ಗಳು ಸಿಕ್ಕಂಗ ಆಯ್ತಂದ್ರ. Okay, now look at here. What is happening? What will happen now? The 3s, 3px, 3py, 3pz and 3dxz, totally 5 orbitals. These 5 orbitals undergo hybridization to form 5 sp3d hybrid orbitals. 5 sp3 hybrid orbitals are formed by 1 3s, 3p and 1 3d orbital of the phosphorus. Okay, this is clear? Okay, with and these 5 sp3d hybrid orbitals are oriented towards the towards the corners of trigonal bipyramidal shape. Trigonal bipyramidal shape. Trigonal bipyramidal ಅಂತಂದ್ರೆ ಏನು? Just assume it is a plane. It is a plane. Here I am having triangle. ಇಲ್ಲಿ ಒಂದು ಇದು ಬಾಕ್ಸ್ ಐತಿ, ಸ್ಕ್ವೇರ್ ಐತಿ, ಇದು ನೀವೇನು ತಿಳ್ಕೊಡ್ರಿ, ಇಲ್ಲಿ ಒಂದು ಟ್ರಯಾಂಗಲ್ ಐತಿ ಅಂತ ತಿಳ್ಕೊಡ್ರಿ. ಇಲ್ಲೊಂದು ಟ್ರಯಾಂಗಲ್ ಐತಿ ಅಂಡ್ ಈ ಕಾರ್ನರ್ಸ್ ಗೆ ಇಲ್ಲೊಂದು ಕ್ಲೋರಿನ್, ಇಲ್ಲಿ ನೋಡ್ರಿ ನಾನು ಬರೀತೀನಿ ಈಗ. ಹಿಯರ್ 1 ಕ್ಲೋರಿನ್, ಹಿಯರ್ 1 ಕ್ಲೋರಿನ್, ಹಿಯರ್ 1 ಕ್ಲೋರಿನ್. ಹಂಗ ಟ್ರಯಾಂಗಲ್ ನ 3 ಎಡ್ಜ್ ಗಳಿಗೆ, ಪಾಯಿಂಟ್ಸ್ ಗಳಿಗೆ, ಅಪೆಕ್ಸ್ ಗಳಿಗೆ ಏನೈತಿ, ಒಂದೊಂದು ಕ್ಲೋರಿನ್ ಐತಿ. 1 ಕ್ಲೋರಿನ್, 2 ಕ್ಲೋರಿನ್, 3 ಕ್ಲೋರಿನ್. What about the remaining 2 chlorines? ಅವೇನಾಗಲ್ಲ, one is above the plane, another one is below the plane. ಹೌದಲ್ಲ? ಈಗ ಹಂಗಂದ್ರೆ ಮೇಲೆ ಒಂದು ಪಿರಮಿಡ್ ಟೈಪ್ ಶೇಪ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತದೆ, ಕೆಳಗಡೆ ಒಂದು ಪಿರಮಿಡ್ ಶೇಪ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತದೆ. Therefore, this is what the trigonal bipyramidal shape. Trigonal bipyramidal shape. Okay, ಇಲ್ಲಿ ಬಾಂಡ್ ಗಳನ್ನ ಬರೀತೀನಿ ಈಗ. Here one bond, PCl bond, here second bond, here third bond. And what about the remaining 2? One is above the plane, another one is below the plane. Here I am writing the bond. Here one bond, here another bond. Okay. This is what the trigonal bipyramidal shape. Trigonal bipyramidal shape. Okay. Here three PCl bonds. Three PCl bonds are arranged in a planar trigonal structure. Three PCl bonds are having arrangement in a planar trigonal structure with a bond angle of 120 degree. 120 degree. ಇವುಗಳ ಮಧ್ಯೆ ಇಲ್ಲಿ ನೋಡಿ 1, 2, 3. These are having what 120 degree bond angle, and these three PCl bonds with a bond angle of 120 degree. These are called as equatorial bonds. These are called as what? Equatorial bonds. These are called as equatorial bonds. ಇವನ್ನ ಏನಂತ ಕರೀತೀವಿ ನಾವು? Equatorial bonds ಅಂತ ಕರೀತೀವಿ ಅಂದ್ರೆ. They are having 120 degree bond angle. They are what? They are having lower repulsion. Why they are having lower repulsion? Because their bond angle is above 190 degree. Any bond angle with above 90 degree are what? They are stable. Okay. And what about the remaining two bonds? Remaining two bonds. ನಾನು ಹೇಳಿದಲ್ಲ ಇಲ್ಲೊಂದು ಟ್ರಯಾಂಗಲ್ ಇರ್ತದೆ ಈಗ. In triangle 1, 2, 3. Here bond angle is 120 degree. What about the remaining two bonds? One bond is here, another bond is here. It means the above and below chlorine atoms are making 90 degree. 90 degree with the equatorial bonds. ಈ ಮೂರು equatorial ಬಾಂಡ್ಗಳ ಜೊತೆಗೆ ಈ ಕ್ಲೋರಿನ್ ಮತ್ತು ಈ ಕ್ಲೋರಿನ್ ಏನು ಮಾಡ್ತಾ ಇದೆ 90 ಡಿಗ್ರಿ ಬಾಂಡ್ ಅನ್ನು ಹೊಂದಿದೆ. ಅಂದ್ರೆ two phosphorus chlorine bonds are at 90 degree. 90 degree. They are called as axial bonds. Because of 90 degree, they experience, these two PCl bonds experience repulsion bond from these three PCl bonds. ಈ ಮೂರು PCl ಬಾಂಡ್ಗಳಿಂದ ಈ ಎರಡು PCl ಬಾಂಡ್ಗಳು ರಿಪಲ್ಷನ್ ಅನ್ನ ಏನ್ ಮಾಡ್ತಾವ? ಹೊಂದುತ್ತಾವು. ರಿಪಲ್ಷನ್ ಅನ್ನ ಹೊಂದುತ್ತಾವ. ಯಾಕೆ? 90 ಡಿಗ್ರಿ ಬಾಂಡ್ ಆಂಗಲ್ ಐತಿ. ಆಲ್ರೆಡಿ ನೀವು ನೋ ದಟ್ whenever any bonds are arranged with a 90 degree, they will be repelled by the other bonds. ಬೇರೆ ಬಾಂಡ್ಗಳಿಂದ ರಿಪಲ್ಷನ್ ಜಾಸ್ತಿ ಇರ್ತೈತಿ. Therefore, these are having less stability, and these three bonds are having more stability. This is about what? PCl5 bond. PCl5 molecule with sp3d hybridization. Okay. Next, move towards the last molecule, that is SF6 molecule. Sulfur hexafluoride molecule. Sulfur hexafluoride molecule. Here, one sulfur atom is there and 6 fluorine atoms are there. Totally 6 SF bonds will be formed. 6 SF bonds will be formed. It means 6 hybrid orbitals are necessary. 6 hybrid orbitals are needed. And 6 hybrid orbitals ಇರತಕ್ಕಂತಹ hybridization ಯಾವುದು? sp3d2 hybridization. 1s, 3p, 4i2, 2d. 6 hybrid orbitals ಗಳು sp3d2 hybridization ಇಂದ ಸಿಗ್ತಾವೆ. ಯಾವುದಕ್ಕೆ? ಸಲ್ಫರ್ ಗೆ. Now let us write the excited state configuration of the sulfur directly. I will write sulfur atomic number 16. It is I am writing excited state configuration of the sulfur. Excited state configuration of very ನೋಡಿ same phosphorus 15 ಇತ್ತು, sulfur 16 ಇತ್ತು. ಇದಕ್ಕಿಂತ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಜಾಸ್ತಿ ಇರಬೇಕು, ಮತ್ತೆ ಎಕ್ಸ್ಟ್ರಾ ಏನಿಲ್ಲ. I am writing exact state configuration 3s1, 3px1, 3py1, 3pz1, 3dxz1, 3d ಅಂದ್ರೆ 6 orbitals are available here. 6 orbitals are available here. Look at here. 1 3s, 3 3p, 2 3d orbitals undergo hybridization to give what? To give 6 sp3 d2 hybrid orbitals. 6 sp3 d2 hybrid orbitals. Okay, 6 sp3 d2 hybrid orbitals ಗಳು ಸಿಕ್ಕುವಂಗಿದೆ. Okay, these 6 sp3 d2 hybrid orbitals are oriented towards the corners of octahedral structure. This is what octahedral structure. Octahedral shape or octahedral geometry. ಯಾವ್ದಂದ್ರೆ octahedral geometry. ಅಂದ್ರೆ octahedral geometry ಯಾವ ರೀತಿ ಇರ್ತದೆ? Look at here. Let us assume it is a square. What I have shown there. See here, it is a square. ಈ ರೀತಿ ಇರ್ತದೆ. Here one corner, here one corner, here one corner. Total 4 corners. And what about the remaining 2 corners? Above this player, one bond. Below this player, another bond. Totally 6 bonds. And ಈ ಕಾರ್ನರ್ ಗಳಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ at the center you can have the sulfur. At these corners I can have fluorine. ಅಂದ್ರೆ with these 6 sp3d d2 hybrid orbitals, the half-filled 2pz orbital of the fluorine undergo axial overlapping to make 6 sf sigma bonds. ಈ 6 sf sigma ಬಾಂಡ್ಗಳು ಹೆಂಗೆ ಪ್ರಿಪೇರ್ ಆಗುವಂತಂದ್ರೆ by the overlapping of 6 2pz half-filled atomic orbital with the 6 sp3d2 hybrid orbitals of the sulfur. They have made 6 sulfur fluorine sigma bonds, and the geometry is like this, the octahedral geometry. Look at here. Here one bond, here second bond, here third bond, here fourth bond, fifth bond, and sixth bond. Okay, this is about what? The sulfur fluorine sigma bonds. This is about what? The hybrid. Here one more thing. Here all the bonds are with the 90-degree bond angle. Please remember this point. Here all the sulfur fluorine bonds are with the 90-degree bond angle. And repulsion is there. The molecule is still existing there. Okay. This is about what? The hybridization with these 6 molecules. Here 4 molecules are I have explained in this class, and in the previous class I have explained 2 molecules, methane and ethane molecule. This is about what? The hybridization. Thank you.